Hello everyone, welcome to my channel. Please like and subscribe. In this video, we'll be learning how to design a cantilever retaining wall step by step, from the first step up to the final step. In the design cantilever retaining walls, there are four main steps to be followed. The first step is to check the soil pressure. The second step is to check the stability of the cantilever retaining wall. The third step is to determine the reinforcement required for the cantilever retaining wall. And the final step is detailing for the reinforcement of the cantilever retaining wall. Now, let's start step by step. In your problem, which states that a cantilever retaining wall is shown below is backfilled. This one is backfilled with the granular materials having a unit weight of 19 kilonewton per meter cube and the internal angle of friction of 30 degrees. Assumes the allowable bearing pressure is 120 kilonewton per meter square. The coefficient of friction is 0.4 and the unit weight of reinforced concrete is kilonewton per meter cube. Now, our data given. In our problem, we have this data. Now, let's start step by step. Data given. Data given. We have given the unit weight of soil. The unit weight of soil is this one. Kilonewton per meter cube. Kilonewton per meter cube. Also, we have given the internal angle of friction, which is 30 degrees. Also, we have given the allowable bearing pressure. Allowable bearing pressure, which is 120 kilonewton per meter square. Also, we have given the coefficient of friction, which is equal to coefficient of friction, which is equal to 0.4. Also, we have given the unit weight of concrete, which is 24 kilonewton per meter cube. Also, we have given the FCU, the strength of concrete, which is equal to 35 kilonewton per meter square. The strength of reinforcement, which is Fy, is 500 kilonewton per meter square. FCU is 35 kilonewton per meter square, which is equal to 35 Newton per millimeter square. Fy, as this is reinforcement strength, which is 500 kilonewton per meter square. Also, we have given the reinforcement curve of the wall and the base. The reinforcement curve for the wall is 35. Curve for wall is 35 millimeter. 35 millimeter. Also, curve for base we have given is 50 millimeter. Also, we have given the diameter of main reinforcement. The diameter of main reinforcement, which is equal to 20 millimeter. As this is our problem, we are required to design step by step up for the final step, which is detail. Now, let's start step by step. In your data, from this problem, by considering this diagram, the first step we are required to determine the base of the retaining wall. The base width of the retaining wall is obtained by taking this is steam wall, this is toy, and this is hill. The width of hill is from this point up to this point, and the width of toy is from this point up to this point, and this is the thickness of steam wall. Okay, now to determine the width of the base is obtained by taking the toy weights plus thickness of steam plus width of wheel. Toy width is 0.7 meter. This is 700 in a meter. It will be equal to 0.7 meter plus 0.4 plus this when divided by 1000 will be equal to 2.9 meter. So it makes the total width of 4 meter. So the width of this cantilever retaining wall is 4 meter. Also the total height from the ground up to the base of this retaining wall is 500 plus 5,000 plus 400 will be equal to 5.4 meter. This is the total height from the ground level up to the base of this retaining wall. Now, let's start designing step by step. The first step is to determine the soil pressure. The soil pressure. The soil pressure. The soil pressure which acting the soil pressure which acting at this soil pressure is active soil pressure, which is given by taking unit weight times coefficient of active pressure times total height of this cantilever retaining wall. Now, this is active pressure. Active pressure is given by taking unit weight times coefficient of friction times overall depth times total depth. Now, how can I determine this coefficient of active pressure? Coefficient of active pressure is determined by taking 1 minus sin angle over 1 plus sin angle of internal friction, which is it will be equal to tan squared theta 45 minus angle over divided by 2. So coefficient of active pressure will be equal to tan squared theta tan square 45 minus 30 divided by 2. It will be equal to 1 over 3. After that, now let's substitute into this formula so as to obtain the soil pressure. So it will be equal to, as the unit weight of soil is this one. The unit weight of soil is 19 kilonewton per meter cube. 19 times coefficient of active pressure, which is 1 over 3 times h total depth, which is equal to 5.4. It will be equal to 19 times 1 over 3 times 5.4. It will be equal to 34.2. This is kilonewton per meter square. This is the active soil pressure acting at this retaining wall. Now, the next step is to check for the stability of the retaining wall. Stability of retaining wall is checked in 3 cases. The first case to determine the sliding. The second one is overturning, and the third is bearing capacity of the retaining wall. Now let's start with sliding. The wall may slide horizontally if the soil pressure exists the friction force which acting at the base of this retaining wall. Factor of safety against this failure mode retaining wall is obtained by taking factor of safety against sliding is obtained by taking friction force over force due to horizontal force due to the earth pressure should be greater than or equal to 1.5. This is factor of safety against this failure mode retaining wall, which is sliding. Now, how can we get this horizontal force, this one, horizontal force due to S pressure. Horizontal force due to S pressure is determined taking the area of this soil pressure diagram. This soil pressure diagram is triangular in nature. So to obtain the area of this, we take the area of triangle, which is taken by taking a half times base. The base of this triangular shape is active pressure times H. This is H, the depth of this triangular shape. So when we multiply, it will be equal to a half times active pressure, which is 34.2 times H which is 5.4. It will be equal to times 0.5 times 5.4. It will be equal to 92.34. Now, horizontal force due to the S pressure, it will be equal to 92.34. This is kilonewton per meter square. Kilonewton per meter. This is kilonewton per meter. Because this active soil pressure was kilonewton per meter square, after multiplying by this 8, it will be equal to kilonewton per meter. This is a horizontal force acting to this soil pressure diagram. Now let's start. Now, how can we gauge this friction force at the base? Friction force is obtained by taking coefficient of friction times total weight of this vertical loads. Now, how this total vertical weight is obtained by taking the weight of steam plus weight of base plus weight of soil. This total weight is obtained by taking this weight of steam plus weight of base plus weight of soil, weight of soil in hill slab. Now, how can we determine this weight? As the weight is obtained by taking the area times the unit weight. Now, weight of soil, weight of steam. Now let's start with weight of steam. Weight of steam is obtained by taking the area of this steam, which is obtained by taking the weight of this steam is obtained by taking the area of this steam. The thickness of this steam is 400, which is equal to 0.4 times depth of this steam, which is equal to 5 meters. So it will be equal to area 0.4, which is base times H, which is 5 meters times unit weight of concrete. Unit weight of concrete. This steam is made of reinforced concrete. So we multiply by unit weight of concrete because it is made of reinforcement concrete strings. Now, times unit weight of concrete which is equal to 24. It will be equal to 48 kilonewton per meter. Now, weight of base. Weight of base is obtained by taking the area of base times unit weight of concrete. This is the base of the retaining wall. Now, the weight of this base is 400, which is equal to 0.4 in a meter, and the height of this, which it will be equal to 4 meters. Now, 0.4 times 4 times unit weight of concrete, which is equal to 24, it will be equal to 38.4 kilonewton per meter. The next is to determine the weight of soil on hill slab. The weight of soil. This is the weight of soil on hill slab. The weight of soil. The weight of soil on hill slab. All of these are the soil which acting on the hill slab. So the weights of hill shrub is 2.9 and its height is 5 meter. Is 5 meters. So its area will be equal to 2.9, which is width times height, which is 5 times unit weight of soil. Because this is a weight of soil hill shrub, we multiply by unit weight of soil, which is 19. It will be equal to 275.5 kilonewton per meter. Now, to determine the total weight of these loads, so total weight will be equal to weight of steel plus weight of base plus weight of soil. Weight of soil, total weight, it will be equal to 48 plus 38.4 plus 275.5. It will be equal to 61.9. This is kilonewton per meter. This is a total weight uh, of the vertical loads. Now let's determine the friction force. Friction force, as before, friction force is obtained by taking coefficient of friction times total weight Now friction force, it will be coefficient of friction is this one 0.4. This one 0.4. 0.4 times total weight, which is equal to 61.9. Friction force, it will be equal to 0.4 times 61.9. It will be equal to 144.76. This is kilonewton per meter. The friction force 1.4476. This is kilonewton per meter. The next is now to substitute into the factor so as to obtain the factor of safety against sliding. Factor of safety against sliding. Factor of safety is obtained by taking friction force of horizontal force due to the S pressure. This should be greater than or equal to 1.5. So friction force we have obtained, which is 144.76 of horizontal force due to the S pressure. This one, horizontal force due to the S pressure is 92.34. 92.34. When we divide here by, it will be equal to 92.34. It will be equal to 1.57. This is greater than 1.5. This, it is okay. This stability against sliding is, it is okay, though may not slide. Hence, the factor of safety against sliding is equal to 1.57. The next stability check is overturning. The wall rotates about story. So factor of safety against overturning is obtained by factor of safety against overturning. Factor of safety against overturning is obtained by taking resistance moment of overturning moment should be greater than or equal to 2.0. Now, how to determine the overturning moment? Overturning moment is obtained by taking this horizontal force due to S pressure times its perpendicular distance, which is h over 3. Now, overturning moment is obtained by taking friction force times horizontal force times its perpendicular distance, which is obtained by taking h divided by 3. Now, horizontal force due to this pressure is 92.34 times h, which is 5.4 divided by 3. Now, overturning moment, it will be equal to 92.34 times 5.4 divided by 3. It will be equal to 166.2. This is kilonewton meter per meter. The next, it determines the resistance moment. Resistance moment is due to the weight weight of the self weight of the self structure, and plus is the weight of soil plus is the weight of soil in hill shrub. Now, this resistance moment it will be obtained as follows. Because the wall rotates about tau, so to obtain this this resistance moment, it will be obtained by taking this weight times perpendicular distance. Because rotates about, so all of these rods will rotate in clockwise direction about, so this is, so it will rotate towards this point. This weight of steam will rotate towards toy. Also, this one rotates towards this one. How to determine the perpendicular distance? This is perpendicular distance. This is perpendicular distance of the steam. It says this is x1, this is x2 about toy. Perpendicular distance from toy up to this rods. Also, this is x3, perpendicular distance of the weight of soil on hill sharp. Now, how to determine this resistance moment? Resistance moment is obtained by taking the weight of steam or plus times perpendicular distance, which is x1, times perpendicular distance, weight of steam times perpendicular distance about tau. This is x1 plus weight of base times perpendicular distance, which is x2. Weight of base times perpendicular distance, which is x2, plus weight of soil times perpendicular distance, which is x3. Weight of soil times perpendicular distance, this one, which is x3. All of this we are plusing because all of this rotates in clockwise directions. That's why we are plus. So how can we determine the value of x1? The value of x1 is obtained by taking this one, x1 is obtained by taking the weights of toy plus, because this load acts at the center of this steam, we take the width of the thickness of steam divided by 2, so it will be equal to 0.7 plus 0.4 divided by 2. It will be equal to 0.9 meter. X2, this is perpendicular distance where up to where this weight of base acts, because is obtained by taking the total weights of base divides by 2. So it's because it acts at the center of the base of the retaining wall. So it will be equal to 4 divided by 2, it will be equal to 2 meters. X3 is obtained by taking, this is X3 is obtained by taking this weights plus 400 plus this weights on hill shrub divided by 2, because the actor is the center of this hill shrub. So it will be equal to 0.4 plus 0.7 plus 2.9 divided by 2. It will be equal to 2.9 divided by 2 plus 0.9. It will be equal to 2.9 plus 2.9 over 2 plus 0.4 plus 0.7. It will be equal to 2.55 meters. Now let's substitute so as to obtain the value of resistance moment. Resistance moment, it will be equal to weight of steam. Weight of steam is 48. We have calculated here 48. Weight of base 34.4, and weight of soil is this one. Weight of soil 275.5. So it will be equal to 48 times perpendicular distance, which is 0.9 plus 38.4 times perpendicular distance, which is 2, plus 275.5 times perpendicular distance, which is 2.55. So resistance moment, it will be equal to, now let's compute this one, times 275.5 plus 38.4 times 2 plus 48 times 0.9. It will be equal to resistance moment, it will be equal to 8 to 22.5. This is kilonewton per meter. Now, let's substitute into this formula of factor of safety for overturning. So it will be equal to factor of safety against overturning. It will be equal to resistance moment, which is 80 to 2.5 divided by 166.2. It will be equal to 4.9, which is greater than 0.2. Hence, the factor of safety against overturning it is okay. So the wall cannot overturn because the factor of safety it is okay. So there was a factor of safety against overturning. Against overturning is 4.9. The next is to check the bearing pressure. The bearing capacity of this retaining wall. The bearing capacity. How can we determine the bearing capacity? The bearing capacity, the next step is for checking for bearing capacity. Bearing capacity. The wall may this failure occur when if the pressure exerted by the wall is greater than the pressure exerted by the soil. So factor of safety against this bearing pressure. The wall may be safe if the maximum pressure exerted by the wall is less than or equal to allowable bearing pressure. This is for safe bearing capacity. So how can you determine this maximum bearing pressure? Maximum pressure is obtained by taking resultant force over base of the retaining wall brackets plus or minus 6 times eccentricity divided by base. So how to determine this? And this formula is applicable if this resultant force lies within the middle side of the middle side. Now, how can you determine the value of eccentricity? Now, let's consider this diagram. Consider this diagram. Now, this is retaining wall, which have this is a thickness of steel. Now, this is the total. This is the base retaining wall. So this, because it has 3 portions, you divide base divided width divided by 3, width divided by 3, width divided by 3. So, and this is the center. Now, its pressure diagram, it will be in this way. Which produces maximum pressure and minimum pressure. Maximum pressure at toy. This is toy, and this is heel. The maximum pressure occur at toy, and the minimum pressure occur at heel. So, and this is the centroid of this base of the retaining wall. And as said, this resultant force should lie within the middle sides. Now let's say this the resultant force which lies at the middle side. This is the middle side. The middle side of the base retaining wall. Middle side. And this is the location of the resultant force. This is resultant force, and this is the location of the resultant force where it acts, and the distance from where the resultant force acts up to the centroid of the base retaining wall is called eccentricity. This is one eccentricity. So how can you determine? And this is base divided by 2. Base divided by 2. Now, how can you determine the location of this retaining wall? After that, we will determine the value of eccentricity. The value of eccentricity now. Let's continue. Let's continue. How can you determine the location of the resultant force? Location of the resultant force is obtained by taking for the stability for the stability for the stability for the stability for the stability. Okay, for the stability, there is a moment due to resultant force should be equal to net